the sixth planet from the Sun and the second largest in the solar system. It is a giant gas sphere with an average radius about 9 times that of Earth. Whenever Saturn is mentioned, we often think of its beautiful rings.
This planet has the most extensive ring system compared to other planets in the solar system.
It is estimated to extend from 7,000 kilometers to 80,000 kilometers from Saturn's equator. But remarkably, the rings are extremely thin. They are primarily composed of ice particles, with the remainder being debris and dust. For a long time, scientists have observed, studied, and analyzed Saturn's rings to explain why the planet has such large rings. After decades of debate and research, they finally have a plausible explanation for this phenomenon. In this video, we invite you to explore the origin of Saturn. Wishing you relaxing moments with us. Now, let's go explore. The rings are an iconic feature of Saturn. They are so distinctive that whenever Saturn is mentioned, people can immediately picture its beautiful rings. Many even associate it as the ringed planet. Saturn's rings were first observed in 1610 by the renowned astronomer Galileo Galilei.
Although at that time, he could not see clearly enough to understand the natural nature of the rings.
By 1655, Christian Huygens was the first to describe them as a disk orbiting Saturn. He used a reflecting telescope of his own design, 50 times more powerful than Galileo's. He then observed and noted that it is surrounded by a thin, flat ring, not touching the planet, tilted relative to the ecliptic plane. This discovery was a historical milestone, making Huygens the first to discover Saturn's rings. Since then, Saturn has always captivated with its unique rings. Many astronomers have tried to find an explanation for the origin of these rings. Debates lasted for decades, with many scientists believing that the rings could have formed along with Saturn about 4.5 billion years ago from icy debris left in orbit around it after the solar system formed. But others argued that these rings are very young, only about 100 million years old. Saturn's tremendous gravitational force tore apart a comet or an icy moon to provide the material for the rings. All of these were just speculations. No one knew the answer for sure. This led to endless debates. And that is also why scientists at the Massachusetts Institute of Technology wanted to find the final answer. Using complex calculations and mapping changes in Saturn's axial tilt over time, the research team found that there must be another celestial body orbiting the planet that we were unaware of. This mysterious celestial body could be an ancient moon, which the research team named Chrysalis. When this moon entered the chaotic region with over 80 moons of Saturn, it underwent several close encounters with 2 other large moons, Iapetus and Titan.
Eventually, it came close to Saturn and was torn apart by the planet's super strong gravitational pull,
causing a catastrophic collision between the 2 celestial bodies, shattering the moon into small fragments that arranged into rings around Saturn, which we call the rings. According to the research team, the collision likely occurred about 160 million years ago. This means that throughout its approximately 4.5 billion years of existence, Saturn did not have rings. They only appeared about 160 million years ago, when dinosaurs on Earth were not yet extinct.
Not only analyzing the age and origin of the rings, the research team also explained
that Saturn's axial tilt is related to its largest moon, Titan. We know that Saturn has a significant axial tilt relative to the ecliptic plane, 26.7 degrees. Since the 2000s, astronomers have believed that Saturn's tilt stems from an orbital resonance between Saturn and its neighbor, Neptune.
Two planets are in resonance, and their orbital periods are synchronized, and they exert regular gravitational influences on each other.
In the new study, scientists used data from the Cassini spacecraft. This data was collected from 2004 to 2017, when NASA's spacecraft orbited the planet. After analyzing the data, scientists believe that Saturn's largest moon, Titan, may be the reason why Saturn is tilted so much. This is because Titan is moving away from Saturn faster than expected, at a rate of about 11 centimeters per year. Therefore, it is believed that the moon's gravity could cause the planet to tilt. This theory is based on Saturn's moment of inertia, or how mass is distributed inside the planet. However, after using the final data from the Cassini spacecraft to model the mass distribution within the planet
and calculate its moment of inertia, the research team was very surprised to find that
the newly determined moment of inertia value places Saturn near, but just outside, the resonance zone with Neptune. This means the planet may have once resonated with Neptune in the past, but currently does not. Then, the research team continued to investigate how Saturn escaped resonance with Neptune. The researchers re-examined the mathematical equations
describing the change in Saturn's rotational motion over time.
They hypothesized that the axial tilt could be affected by the loss of a moon, as this could cause it to lose resonance with Neptune. And the culprit behind all this may be the hypothetical 84th moon, Chrysalis. The research team concluded that, while in orbit, Chrysalis pulled Saturn in a way that kept its tilt in resonance with Neptune. However, this moon may have entered a chaotic orbital region around 200 to 100 million years ago, and experienced several close approaches with the moon's Iapetus and Titan. Finally, it came too close to Saturn around 160 million years ago. The collision tore Chrysalis into many pieces, causing Saturn and Neptune to lose resonance due to the moon's gravity no longer being present. Titan's continuous outward movement and its influence on the resonance between Saturn and Neptune
caused Saturn's tilt to subsequently decrease, though still maintained its current value of 26.7 degrees.
A small portion of Chrysalis's mass remained in orbit, breaking into ice chunks and forming the rings. That is the entire story of how Saturn's impressive rings formed.
Besides their mysterious origin, there are many other interesting things surrounding Saturn's rings.
Many people might think that Saturn's rings are tightly packed circles, but that is not actually the case. If we could zoom in on the rings, we would see they have significant gaps. For example, the Cassini division or the Encke gap can be seen directly from Earth. Meanwhile, the Voyager spacecraft discovered that the rings have a complex structure with thousands of gaps and alternating ringlets.
The main composition of the rings is primarily water ice, accounting for up to 99.9%, along with some other impurities.
The water ice particles in the main rings range in size from 1 centimeter to 10 meters. The estimated total mass of the rings is 3 times 10 to the 19 kilograms, very small compared to Saturn's mass. However, there are also opinions that this mass estimate may not be accurate, and the actual mass could be about 3 times heavier. S rings also have their own atmosphere, independent of the parent planet. This atmosphere is composed of molecular oxygen gas, created when ultraviolet rays from the sun interact with the water ice of the rings. According to models of this atmosphere, hydrogen is also present. The oxygen and hydrogen molecules in the atmosphere are very sparse. Therefore, if the entire atmosphere were compressed to the size of the rings, that atmosphere would only be as thick as one atom. So today, you and I have explored the origin of Saturn's vast rings.
Wishing you an enjoyable video. Don't forget to like, share, and subscribe to the Oddity Odyssey channel to follow the latest videos. Hello and see you again in future videos. Goodbye, everyone. Subscribe to the Lala School channel so you don't miss exciting videos.